Hello everyone. We have been learning the solutions of the questions from exercise 9.1 for class 10th from NCERT, that is based on heights and distances, or we say applications of trigonometry. In this video we will be starting question number 11 onwards on the same exercise. Question number 11 here is a TV tower stands vertically on a bank of a canal. From a point on the other bank directly opposite to the tower, the angle of elevation of the top of the tower is 60 degree. From another point 20 meters away from this point on the line joining the point to the foot of the tower, the angle of elevation of the top of the tower is 30 degree. Find the height of the tower and the width of the canal. To draw the diagram for this particular problem, we are having AB be the tower and BC be the width of the canal. Suppose it is X. The angle of elevation from C to the top of the tower is 60 degree. 20 meters away from C, let the point be D, and from this D we are getting the angle of elevation is 30 degree. We have written the subscription here. Let the tower be AB and AB equal to H. Suppose the height is H. Let BC equal to X be the width of the canal. Angle C is 60 degree and angle D is 30 degree. It is also given that the distance between the points is 20 meters. So DC is equal to 20 meters. To find the values of X and H, we will be applying the conditions in these two triangles, that is ACB and ADB. In triangle ACB, we are having the height of the tower is H and the width of the canal is X. This is the perpendicular, this is the base, and we know that perpendicular upon base is the trigonometric ratio, that is tan theta. So we will be applying here tan theta. Tan theta here is AB upon BC. Theta is 60 degree. So we are having here tan 60 is equal to AB is H, BC is X. From the table we know the value of tan 60 is root 3. So this is root 3 is equal to H upon X. Multiplying X here, we get the value of H as X root 3. This we can write as equation number 1. Now we come to triangle ADB. In triangle ADB, again we are having the perpendicular and the base. So we will be applying tan theta here also. Tan theta is equal to AB upon BD. Here theta is 30 degree. So this will be tan 30 is equal to ABH. BD here is X plus 20. We know the value of tan 30 is 1 upon root 3. That is equal to H upon X plus 20 here. When we cross multiply them, we are getting X plus 20 equal to root 3 into H. This we can take as equation number 2. We have to find the value of X and H both. From here we can take the value of H, X root 3, and we can substitute it here. If we substitute that, we are getting X plus 20 equal to root 3 into root 3 X. We have used here equation number 1. So we are getting here X plus 20 equal to 3X, which gives us the value of X as 10. After getting the value of X, we can substitute that in 1. From 1, we can get the value of H as X means 10 into root 3. So we are getting here the height of the tower is equal to 10 root 3 meters and width of canal is equal to 10 meters. This is the way we can find out the solution of this particular problem. Now we will be proceeding to question number 12. Question number 12 here is, from the top of a 7-meter high building, the angle of elevation of a cable tower is 60 degree and the angle of depression of its foot is 45 degree. Determine the height of the tower. To draw the diagram of this particular problem, we are taking here, let AB be the building of height 7 meter and CD be the cable tower and the height of this is suppose H. Here CE, this is equal to AB, that will be 7, and since we have taken the total height as H, ED will be H minus 7. So ED is equal to H minus 7 meter we have written. Angle of elevation from B to D is 60 degree and angle of depression from B to this C is 45 degree. It means angle C will be equal to this since they are alternate interior angles. We can consider the distance between the building and the tower be X. So we can write let AC be X, and also we will find AC is equal to BE and that also will be equal to X. Now we use triangle BED. In triangle BED, we have here the perpendicular and this is the base. So we can write P upon B, that is perpendicular upon base. Trigonometric ratio for this is tan theta. So we apply here tan theta. Tan theta is equal to perpendicular, that is DE. Base, that is BE. Theta is 60 degree. So tan 60 is equal to DE, that is H minus 7, BE, that is X. We know the value of tan 60 is root 3. So here we find root 3 equal to H minus 7 upon X. If we multiply this X here, we are getting H minus 7 is equal to root 3X. This we can take as equation number 1. Now we use triangle ACB. In triangle ACB, here again we have this as perpendicular, this as base. So we will be applying tan theta and tan theta is AB upon AC. Theta here is 45 degree. So tan 45 degree is equal to AB means 7. AC means X. And we know the value of tan 45 is 1 is equal to 7 upon X. It means X is equal to 7. Applying this value of X here in 1, we are getting from 1 H minus 7 is equal to root 3 into 7. Transposing this 7 onto that side, we get H is equal to 7 root 3 plus 7. We take 7 common. This is root 3 plus 1 in the bracket, which is the height of the cable tower. So we can write therefore the height of the cable tower is equal to 7 into root 3 plus 1 meter. This is the answer to this problem. Now we are proceeding to question number 13, which is, as observed from the top of a 75-meter high lighthouse from the sea level, the angles of depression of two ships are 30 degree and 45 degree. If one of the ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. To draw the diagram, we consider AB be the lighthouse of height 75 meter. Let C and D be the positions of the ships and the distance between them be Y. The distance AC is suppose X. Now angles of depressions have been given as 30 degree and 45 degree. So these angles being the alternate interior angles will be 45 degree and 30 degree respectively, which we have mentioned here. For the solution, first we go in triangle BCA. In triangle BCA, We find here this is the perpendicular, this is the base, and we know perpendicular upon base is tan theta. So we apply here tan theta, and tan theta here is AB upon AC. Here theta is 45 degree, so we get tan 45 degrees equal to AB means 75, AC is X. We know the value of tan 45 is 1. So this is 1 equal to 75 upon X. Cross multiplying we get X is equal to 75. Now we can go to triangle BDA. In triangle BDA, we apply tan theta here also, and tan theta here is perpendicular is AB. Base is AD. Theta is 30 degree, so tan 30 is equal to AB means 75, and AD here comes as X plus Y. We know the value of tan 30 is 1 upon root 3 from the table. 1 upon root 3 is equal to 75 upon X plus Y. Cross multiplying we are getting X plus Y is equal to 75 into root 3. We can substitute the value of X from here 75. So we are getting 75 plus Y is equal to 75 root 3. Transposing this 75, we get Y is equal to 75 root 3 minus 75. If we take 75 common into root 3 minus 1. So we find here Y is 75 into root 3 minus 1. It means the distance between the ships is 75 into root 3 minus 1 meter. So we can write hence the distance between the ships is equal to 75 into root 3 minus 1 meter, which is the answer to the problem. Now we will proceed to question number 14. Question number 14 is a 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meters from the ground. The angle of elevation of the balloon from the eyes of the girl at any instant is 60 degree. This is the 160 degree. After some time the angle of elevation reduces to 30 degree. After some time the balloon from here, suppose this is the balloon, it moves in this direction and then it goes from B to D at the same height. Find the distance travelled by the balloon during the interval. We have to find the distance it is covering from B to D, and same is the distance from A to C. From the diagram we are finding that suppose P is the position of the girl, AB is the first position of the balloon, and then CD is the second position of the balloon. From the ground, this is the position from here to here, and the total height has been given as 88.2. The height of the girl is 1.2 meter. It means this CD will be 87 meters. 88.2 minus 1.2, that is 87 meter. Here we consider that the distance moved by the balloon is BD, that is equal to AC. Suppose AC is equal to Y, and distance AP is suppose X. So PA we have considered as X, AC we have considered as Y. We have to find out the value of Y from this. So we use the triangles here. First we go in triangle PAB. We see here that this is the height with us and this distance we have to find. So this is perpendicular upon base is to be applied, which is equal to tan theta. So we apply here tan theta, and this triangle tan theta is AB, that is the perpendicular, upon PA, that is the base. Theta is 60 degree, so this becomes tan 60 is equal to AB means 87 and PA is X. We know the value of tan 60 is root 3, so root 3 is equal to 87 upon X. Multiplying we are getting here root 3x is equal to 87, or we can say x is equal to 87 upon root 3. This we can take as equation number 1. Now we take triangle PCD. In triangle PCD, again we have to apply tan theta only, and in this case tan theta is CD, that is perpendicular, upon base is PC. Theta is 30 degree. So tan 30 is equal to CD, that is 87, and PC, that is here x plus y. From the table we know the value of tan 30 is 1 upon root 3. So this becomes 1 upon root 3 is equal to 87 upon x plus y. Multiplying this we get x plus y is equal to 87 into root 3. This we can consider as equation number 2. From the first equation we substitute the value of x here. We are getting this as 87 upon root 3 plus y is equal to 87 root 3. By transposing, we get the value of y as 87 root 3 minus 87 upon root 3. 87 we are getting common, root 3 is the LCM, this comes as root 3 into root 3, that is 3 minus 1. So this becomes 87 into 2 upon root 3. If we rationalize, we can multiply this by root 3 in the numerator and denominator both. Then we are getting here y is equal to 87 into 2 into root 3 upon 3. 3 cancels this 29 times. And 29 to the 58, so this comes as 58 root 3 meters. So we can write this implies that distance covered by the balloon is equal to 58 root 3 meters. This is the answer to the problem. Now we will proceed to question number 15. Question number 15 is: a straight highway leads to the foot of a tower. A man standing on the top of the tower observes a car at an angle of depression of 30 degree, which is approaching the foot of the tower with a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degree. Find the time taken by the car to reach the foot of the tower from this point. To draw the diagram, here we find AB be the tower, suppose. D is the first position of the car from where it is approaching the foot of the tower. C be the second position where the angle of depression becomes 60 degree. These are the angles of depression, 30 degree and 60 degree, and same will come here, 60 degree and 30 degree, because they are alternate interior angles. We consider that the height of the tower is h, and suppose the speed of the car is x. So we write here, let AB be the tower, D be the first position of the car, and C be the second position. Let AB be h, the speed of car be x meters per second, suppose. Then DC is the distance covered by the car in 6 seconds, so this will be 6x, and CA is equal to x into t, or we can say tx if time taken is t. Angle C here is 60 degree and angle D is 30 degree. So we are going to use triangle BCA and triangle BDA. In triangle BCA, see here, this is the perpendicular, this is the base, so we will be going for tangent tan theta, because perpendicular upon base is tan theta. So we find here tan theta is equal to perpendicular is AB, base is AC. Theta is 60 degree. So this is 10, 60 is equal to AB means H and AC means T into X. We know the value of tan 60 from the table is root 3 equal to H upon TX. Cross multiplying, we are getting root 3 into T into X is equal to H. This we can take as equation number 1. Then we go in triangle BDA. In triangle BDA, again we have to apply tan theta only. Tan theta is perpendicular, that is AB, base, that is AD. Theta here is 30 degree, so this will give us tan 30 is equal to AB means H. AD here is TX plus 6x, because that is this plus this. We know the value of tan 30 from the table is 1 upon root 3. This is H, and if we take x common here from both, it will be T plus 6. This is equation number 2. If we substitute the value of H from equation number 1 in 2, what we will get here? 1 upon root 3 is equal to H means this is root 3 into T into X upon X into T plus 6. Here X cancels X. And when we cross multiply, we are getting T plus 6 into 1, that is T plus 6, equal to root 3 into root 3 is 3, that is 3T. Transposing T, we are getting 3T minus T is equal to 6. It means 2T is equal to 6, or we can say T is equal to 6 by 2, that is 3. It means the time taken by the car from C to A is 3 seconds. We can write, hence the time taken by car is equal to 3 seconds. This is the answer to the problem. So we have found the solution of all the questions from exercise 9.1, and I hope you must be finding this video very useful. Subscribe the channel if you have not subscribed it so far. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.